Look, if you're a parent, you already know the exhausting reality of child sleep struggles. We've all lived the long nights, those brutal early mornings, and the sheer desperation that hits when your little one just won't settle down. But today, we're going to move past all that frustration. In this explainer, we're diving deep into the fascinating first principles neurobiology of how pediatric sleep actually works. By the end of this, you're not just going to have another list of generic tips, you are going to truly understand the cellular, neurological, and physiological mechanisms that control your child's brain and body.
So let's start with the ultimate biological puzzle, right? Why on earth does a newborn sleep for 16 hours a day, yet seemingly refuse to sleep when the rest of the world actually does? I mean, parental exhaustion isn't just bad luck, it's deeply rooted in the developing infant brain. To solve this puzzle, we have to look right under the hood of human biology.
Here's our roadmap for today. We're going to cover the biology of pediatric sleep, how much sleep kids actually need, the difference between nightmares and night terrors, the truth about melatonin, and finally, building better sleep habits.
Okay, Section 1, the biology of pediatric sleep and the two-process model. To fix sleep, we've got to first understand the two distinct biological mechanisms driving it. It's a finely tuned evolutionary system known as the two-process model. The first half is process S, or the homeostatic sleep drive. Think of this exactly like an internal pressure valve. From the absolute second a child wakes up, a neurochemical called adenosine begins accumulating in a brain region called the basal forebrain. The longer they're awake, the higher this chemical pressure builds. And eventually, this neurochemical accumulation literally forces the brain into a state of sleep just to clear that adenosine out. It's a biological inevitability.
But here's the thing, sleep pressure is only half the equation. The counterforce to this is process C, the circadian rhythm. Deep inside the brain's hypothalamus sits the suprachiasmatic nucleus, or SCN. This is the master biological clock. It actually uses light and dark cues transmitted directly from the eyes via the retinohypothalamic tract to perfectly time the release of hormones. Basically, it tells the body when it's day and when it's night.
And this interplay right here perfectly answers our opening question. From 0 to 6 weeks, a newborn's suprachiasmatic nucleus it's simply too immature. They have absolutely no established circadian rhythm, which results in highly fragmented polyphasic sleep. It actually isn't until about 6 to 12 weeks that rhythmic endogenous melatonin secretion begins in response to darkness. Then finally, between 3 and 6 months, circadian consolidation actually occurs, allowing for those longer, highly anticipated nighttime sleep blocks. So they aren't being stubborn. Their brains are literally just under construction.
Section 2. How much sleep kids need. The biological baselines.
So these recommendations from the American Academy of Sleep Medicine, they are not just polite suggestions. They are biological necessities. Pediatric sleep architecture contains proportionally way more slow-wave deep N3 sleep than adult sleep. Why? Because this specific deep sleep state is absolutely required for neuroplasticity and the massive secretion of growth hormone. Falling below these hours directly restricts a child's physical and cognitive development. It's that simple.
Now this reveals a massive misconception we have about tiredness. When adults don't sleep, we get sluggish and groggy, but sleep-deprived kids rarely act tired. Instead, their impaired prefrontal cortex manifests as paradoxical hyperactivity, that dreaded second wind. This lack of emotional regulation, the irritability, the poor focus, it frequently mimics the exact symptoms of ADHD.
We really have to recognize why this matters so deeply. Sleep deprivation isn't just about crankiness. It's a profound chronic stressor. It triggers the systemic biological cascade, activating the hypothalamic pituitary adrenal, or HPA, axis. This floods the child's body with elevated cortisol, completely deregulating their autonomic nervous system. Long-term, this sleep debt increases risks for metabolic disturbances like insulin resistance and severely impairs executive function. It is a full system tax on a growing body.
Section 3. Nightmares versus night terrors. Diagnosing the disruption.
Parents frequently confuse two very biologically distinct events that happen in the middle of the night, and understanding the difference dictates exactly how you should react. Nightmares are a psychological response happening during REM, or rapid eye movement sleep, usually in the second half of the night. The child wakes up, remembers the scary dream, and responds beautifully to your comfort. Night terrors, on the other hand, are a neurophysiological hyperarousal trapped in deep, slow-wave N3 sleep, usually in the first few hours of the night. The child might be screaming with their eyes wide open, but they are fully asleep, amnesic, and will very likely push you away if you try to comfort them.
The biological logic here is absolutely critical. Forcing a child awake during a night terror abruptly interrupts that non-REM to REM sleep transition. This causes severe disorientation and actually prolongs the event. Your only clinical interventions are patience and ensuring physical safety. However, for recurring terrors, you can use scheduled awakenings. By gently waking the child just 15 minutes before the typical onset time, you slightly alter their sleep architecture, effectively bypassing the abrupt neurological transition that triggers the terror in the very first place.
Section 4. The truth about melatonin. Is it a biological aid or an unregulated crutch?
We have to tackle a massive trend in modern parenting right now, the heavy reliance on over-the-counter melatonin. Now, while it is a hormone natural to the human body, medical authorities like the American Academy of Sleep Medicine urge high caution. Why? Because it's classified as a dietary supplement, meaning melatonin operates in this regulatory gray area. It is simply not subject to the rigorous FDA oversight that prescription medications require.
And the hidden trade-offs here are deeply concerning. Studies actually show that melatonin gummies and chewables can have wildly inaccurate dosing, sometimes containing over 4 times the amount stated on the label. No way, right? Beyond the immediate side effects like morning grogginess or increased bedwetting, there is a profound lack of long-term safety data. Specifically, the scientific community is still really uncertain about how chronic exogenous melatonin impacts the hypothalamic pituitary gonadal axis during a child's pubertal development. Now, if behavioral interventions fail and a pediatrician does prescribe it, following these strict protocols is vital. First off, it's not recommended for healthy children under 3. You should always start with a microdose of 0.5 to 1 milligram, and, crucially, exclusively use products bearing the USP verified mark. That mark guarantees the product actually contains the exact ingredients listed without any harmful contaminants.
Okay, Section 5. Building better sleep habits and regulating the nervous system.
The ultimate behavioral solution isn't about forcing sleep, it's about aligning the child's environment with their neurobiology, and we really cannot talk about sleep environments without addressing the blue light threat. Short wavelength blue light, specifically between 450 and 480 nanometers from tablets and TVs, hits the retinal ganglion cells right in the eyes. Because pediatric eye lenses are highly transparent, this light transmits directly to the suprachiasmatic nucleus, powerfully suppressing the brain's natural melatonin synthesis. Screen time literally hacks the brain's biological clock, making a strict 60-minute digital curfew absolutely necessary if you want restorative sleep.
So, to counter this, we use the 10-5-3-2-1 routine. This isn't just about being organized for the sake of it, it's about physical cueing. By shifting to low-energy activities like reading physical books, managing hygiene, and systematically powering down, this exact countdown signals the autonomic nervous system that the environment is safe. It allows the homeostatic sleep drive and the circadian clock to align perfectly, releasing natural melatonin and seamlessly transitioning the child into high-quality, restorative sleep. I want to leave you with this thought. The next time you face a daytime meltdown, extreme hyperactivity, or an inability to focus, take a step back. Try viewing it through the lens of nervous system regulation and sleep architecture. Is it really a discipline issue, or is it a biological cry for deeper, more restorative rest? By respecting the science of sleep, we don't just survive the night. We give our children the neurological foundation they need to absolutely thrive during the day.